Do you want to learn how to make your room cooler, ceiling fan or exhaust fan automatic? Then watch this tutorial from start to the very end, because at the end of this tutorial you will be able to make your own temperature control system that can be used to control room coolers, ceiling fans, exhaust fans, etc. This design control system can be used for both AC and DC fans. In this tutorial, we will be using DHT11 sensor. Well, we can also use LM35 or any other temperature sensor, but if you look at the prices of both the sensors, then DHT11 is the best choice, as it also gives you the humidity values, and moreover, DHT11 programming is much more easier than the LM35. In my previous tutorials, I have also used other temperature sensors like K-type thermocouples, which are most commonly used in industries, used for monitoring temperatures up to 1000 centigrade. I have also used BMP 180 sensor, which gives you temperature, pressure and altitude values. But for this project, DHT11 is best. In this tutorial, I will cover the following. Number 1, DHT11 sensor datasheet, pinouts and soldering. Number 2, relay driver circuit designing and soldering. Number 3, interfacing. Number 4, programming. And finally, number 5, testing. Let's get started. Welcome back my friends, and let's start with the datasheet of the DHT11 temperature and humidity module. This is the temperature sensor that we are going to use today in this episode. This datasheet consists of all the informations that you want to know about the DHT11. For example, its product overview, and number 2, the applications, which clearly explains that where you can use this particular sensor, the features, the dimensions, and the product parameters, which is the most important part, and you should give it a read, like the relative humidity, the resolution, the temperature, the electrical characteristics, which tells you that how much power you can give. The power supply is 3.5 to 5.5 volts DC, as in Arduino we already have the 5 volts, so we can power this up using the Arduino power supply. And the pin description, as we know that the DHT11 has 4 pins, so the leftmost pin, which is the pin number 1, can be connected with 5 volts of the Arduino, and the pin number 2 is the data pin, and pin number 3 is not connected, and the pin number 4 is the ground one. So my friends, this is the typical circuit. Over here you can see that the pin number 1 is connected with VCC, which is 5 volts, and pin number 2, which is a data pin, is connected with P3.0, but it's also connected with a resistor, and on the other end of the resistor a 5 volt supply is connected, and pin number 3 is not connected, and pin number 4 is ground. So it means that while using DHT11 we will also be connecting a resistor. So if you read all these information, you will clearly understand that why we are adding a resistor over here. Due to the tutorial limitations, we can't go into all the details. You should give it a read and you will understand that why we are using a resistor over here. So my friends, this is the basic circuit diagram, which shows that how the DHT11 will be connected with the Arduino. As you know that the DHT11 has 4 pins, 1, 2, 3, 4, and the pin number 1 is connected with plus 5 volts. This 5 volt we will be providing from the Arduino, and the pin number 2 will be connected with pin 12 of the Arduino, and as you can see the pin number 12 is also connected with a 10k resistor, and the other side is connected with 5 volts. The pin number 3 will not be connected, and the pin number 4 is connected with ground. So that's all for the circuit diagram. Now we will make this circuit on a Vero board. We will do the soldering, then after that we will interface the circuit, and then we'll start the programming. We will solder the DHT11 sensor onto the Vero board, as you can see. So first of all we will solder one leg of the DHT11 sensor onto the Vero board so that we can align this, and then after that we will use the alligator clips to solder the remaining pins. While soldering, make sure that you don't apply too much heat, because this can damage the DHT11 sensor.
So
now as you can see, there is no short circuit, and we are doing all the soldering as per the circuit diagram which you can see. So now it's time to solder the 10k resistor as per the schematic. So now the 10k resistor is soldered. Now it's time to solder the wires. This is the 5-volt wire which is connected with pin number 1 and one side of the 10k resistor, and now this is the ground wire on pin number 4 and the green wire is on pin number 2. So all the wires are soldered. So my friends, this is the complete circuit diagram of the temperature controlled fan, and this circuit was designed in case of Eagle 6.3.0 professional version. If you want to learn how to make schematics and PCBs, and you can watch my tutorials. So we have already covered the DHT11, its connections and pinouts. So the pin number 2 will be connected with pin 12 of the Arduino. So if you look over here, you can see that the fan will be controlled with the help of an SPDT relay, and so over here you can see a 12-volt wire is connected directly with the fan, and the ground wire is connected with the normally open of the relay, and then the common is connected with the ground. So when we turn on the relay, this contact will connect with this one, so this will short with this one, and it will make a connection, and the fan will turn on. And when we turn off the relay, then connection will break and the fan will turn off. So this is for the DC fan. So if you want to control an AC fan, the connections are same. Then in that case, you will connect one side with the live wire and the other one with the neutral. So the connections are exactly same. So over here you can see we are using a 2N2222 NPN transistor to control this relay, because this relay is at 12 volts and this cannot be controlled directly with Arduino Uno. So for that we need a driver circuit. So the driver circuit actually consists of a 10k resistor and an NPN transistor. So after the circuit explanation, then I will teach you how you do the calculations for the relay driver circuit. So in that we will cover the relay driver circuit design calculations. So that's it. It's very easy, and then the relay is controlled with the help of pin number 13, and that's a complete circuit diagram, and I will provide a link in the description from where you can download the circuit design and the codes, and I will also provide the components prices so that you can purchase the components from the Amazon if you want. So I will search the components with best prices for you guys so that you can directly purchase from the Amazon. So now let's start the relay driver circuit design calculation and soldering. So my friends, first of all, let's start with the components that we will be needing for making our own relay module. If you want, you can also use a ready-made relay module, but if you want to learn how to make your own relay module, how to find pins of an SPDT type relay, how to perform the relay driver design calculations, then you should definitely watch this. And so let's get started. So let's start with the 2N222 transistor. The leftmost leg is the emitter, the middle leg is the base, and the rightmost is the collector. We also gonna be needing a 10k resistor, a DC socket which will be used to power up the relay module, a Vero board, and an SPDT type relay which has 5 legs, as you can see. So this is the common, these two are the coil pins, and this is the normally closed, and this one is the normally open. Let's start with finding the legs of the relay, and then we'll perform the design calculations, and then after that the soldering. So let's start. So my friends, this is the SPDT type relay, which stands for the single pole double throw, and this is the schematic symbol of the SPDT type relay. And we know that it has 5 legs, as you can see clearly. 1, 2, 3, 4, 5. It has 5 legs, and out of these 5 legs, the one is the normally closed, the normally open, and common, and 2 are the coil pins. But actually we don't know, as over here there is no information about the coil pins, about the normally closed, normally open, and common. So first of all, we will find the pins that which one is the normally closed, which one is the normally open, which are the coil pins and which is the common pin, because we have to find these pins, because if we don't know about the relay pins, then how we can perform the relay driver circuit design calculations. So for the design calculations we need to find the pins. So let's start. So my friends, for finding the relay pins we will be using this digital multimeter. So first of all, set this on 2K and turn this on. So first of all we will start with finding the relay coil pins. So for that we will check all these pins, so one by one. So first of all check these two pins, and you can see there is no resistance. So check this one with this one, with this one, with this, and no, and now this one with this, this one. Okay, now this one and this one. Yeah, we got resistance. So my friends, these two are the coil pins, and let's confirm again. So connect one terminal with this leg and one with this, and you can see the resistance is 0.433. So here is a coil, and R is equal to 0.433 kilo ohms, which is equals to 433 ohms. Okay, so now we have the remaining three legs, this one, this one, this one, and now we have to find that which one is the normally closed and which one is a normally open. So for this, set the DMM on the continuities. Okay, so now my friends, we have these three legs remaining which we have to find. So this is the middle one, actually the middle one, this one and this one. So we have to find that which one is a normally closed, which one is the common, and which one is a normally open. Now one by one we have to check all these three pins. So first of all connect this with this one, and with this leg. So there is no beep sound. Okay, now connect this with the middle and this one. There is no sound, and you can hear that there is a sound. So it means that this is normally closed and this is normally open, and this is the common. So the middle one is the common, and as we are holding it like this, so when we hold it like this one will become the normally closed. So this is the normally closed and this one is the normally open. So that's how we can find the relay pins. So now let's perform the design calculations. We have already found the resistance, and now it's time to use a formula, and for this the formula is V equals to IR. And as we know that it's a 12 volts relay, so 12 equals to I multiplied into N. The resistance we have already found this, so 433. Now the current will be equals to 12 divided by 433. So my friends, we get this value, which is 0.027 amps. So let's convert that into milliamps. So it will be equal to 27 milliamps. So now from this value we have to decide that which transistor actually we have to use. So as I'm using an NPN transistor, so I will search for an NPN transistor. So a type of NPN transistor whose collector current is greater than 27 milliamps. So you can find on the internet, like there are thousands of NPN transistors, but you have to select the one which is easily available in the market, which is cheap. So I recommend that you should always use 2x222 transistor for the relay driver circuit design calculations, because this type of transistor is easily available in any electronic shop, and it can its collector current is greater than 600 milliamps. So this is like perfect transistor for the relay driver circuit design calculation. It's really cheap. So now it's time to start the soldering. Instead, let's first apply some solder to the red wire and then apply solder to the black wire. Now we will connect these two wires with the DC socket. So first of all, apply some solder so that we can easily connect. So first of all, we will solder the black wire, and now we will connect the red wire. So as you can see, the wires are soldered. This is the DC socket, and now we will connect the terminal block, so with which then we can later connect an alarm or a DC load. So we will solder the pins, as you can see. Okay, now the soldering is done for the block terminal. So now apply some silicone on the relay. And now you can see. So now we will solder the 2N222 transistor. So you will solder the legs and make sure that you don't apply too much heat, because it can damage the 2N22 transistor. So the soldering is done for the 2N222 transistor. Now we will connect a 10K resistor with the base of the 2N222 transistor. Here you can see the legs. So now apply solder, and again don't apply too much heat, as it can damage the electrical components. So now we'll connect this yellow wire with the 10K resistor. The wire is connected. Later we will connect this wire with pin 13 of the Arduino Uno. Now we will apply some solder to two black wires. So the one wire will be later connected with the ground of the Arduino, and the other black wire is coming from the DC socket. And we are connecting this with the 2N222 transistor emitter pin. So as you can see, now the red wire will be connected with one leg of the relay, which is the coil pin. So it doesn't matter which side you connect this. So one side of the relay coil will be connected with 12 volts, and the other side then will be connected with the collector of the 2N222 transistor. So over here we are connecting the red wire, which is coming from the DC socket. Now you can see the red wire is connected with the relay one coil, and the other wire is connected with the 2N222 transistor emitter. And now this other side of the relay coil will be connected with the collector. So solder this wire, and now the other side will be connected with the collector. So as you can see clearly, this wire is coming from the relay and will be connected with the collector of the 2N222 transistor. So now let's solder this. Now let's apply some solder to the wire, and also to the other side. Take another wire and apply solder to both the ends. Now we'll connect these two wires with the terminal block. So one wire is soldered, and now solder another wire with the other leg of the terminal block. Now solder these wires with the normally open and common pins of the relay. So now we connected this green wire with the common of the relay, and now the blue wire will be connected with the normally open of the relay. So friends, you can see all the soldering is completed. The DC socket is connected, the red and the black wires are connected, and this wire will be connected with the Arduino ground. So that's it. Now our soldering is complete. The common is connected, the normally open is connected. So friends, as you can see, all the components are interfaced with the Arduino Uno board. This is the DHT11 circuit board. I already explained its circuit design and the soldering. It's connected with pin 12 of the Arduino, and its ground pin is connected with the ground, and the VCC pin is connected with the 5V of the Arduino. And this is the relay module. I already explained this in very detail in the circuit diagram, and then we did the soldering. And now I have connected these two wires so that I can easily connect with this with a DC room cooler, or with an exhaust fan, or with a ceiling fan. So, and over here you can see a female DC socket which is connected with the relay module for supplying 12 volts, and it's connected with pin 13 of the Arduino. So as you can see over here, and so that's it. We'll connect 12 volts over here, and I will simply connect this with a laptop, or you can also connect this with a 12 volt adapter. So in this tutorial I will connect this with a laptop so that you can see the temperature on the computer serial monitor. So that's the interfacing, and now we will start the programming. So my friends, this is the program written for the temperature control fan, and before you start the programming, first of all make sure that you download the library for the DHT11 sensor, which is the dht.h, and so .h means that it's a header file, and the hash includes means that it's a preprocessed directive. So as I explained in the circuit diagram that the DHT11 sensor will be connected with pin 12 of the Arduino, so that's why I'm using 12 over here. So hash define DHT pin 12. Now then hash define DHT type DHT11. So if you're using DHT22 or DHT21, then you can simply uncomment this, and you will have to comment this one. So and one more thing about the DHT11 is that it only will give you the positive temperature, and if you want to read the negative temperature, then definitely you can use then the DHT22. So, and then this is the information about the connections, but I already explained this in the circuit diagram. And then over here we have a function which takes two arguments, is the input, which is the DHT pin and the DHT type. The DHT pin is already defined over here and the type is this one. So then after that, the boolean T flag equals to false. Well, actually it's a flag which will be used for monitoring the temperature, so that we don't want to execute the instruction again and again. So this flag will help us, and this flag will be used to stop the unnecessary repetition of the code. And if you want to learn in detail how to use flags in Arduino programming or any other language, you can watch my tutorial. I have a very detailed tutorial on how to use flags in Arduino programming. And as in the circuit diagram I explained that the relay will be connected with pin number 13, so that's why over here integer relay equals to 13. And then, as you know my friends, that each and every Mega and Arduino program has at least two functions. The one is white setup and the white loop. So we start with the white setup. So first of all we activate the serial communication for printing the temperature data on the serial monitor. So we'll be using 9600 baud rate, and serial.print DHT11 test, and then DHT.begin. We start the DHT sensor, and then pin mode relay as output, as we know that it will be used to control a fan or an exhaust fan or ceiling fan, so that's why it's an output device. And then digital write relay as low, so we will keep the load which is connected with the relay, which is in this case is a fan, a DC fan or an AC fan, so it will be off by default. And then we start with a white loop. Wait a few seconds between a measurement, so that's why I'm using 2 seconds delay. 2000 milliseconds equal to 2 seconds, and reading temperature or humidity takes about 250 milliseconds. So sensor readings may also be up to 2 seconds old. It's a very slow sensor. So integer h equals to DHT dot read humidity. So the h will have value of the humidity, and the t will be having value of the temperature in Celsius and centigrade. So in this tutorial I'm using only the this one, so T we will only use to access the temperature value. I'm not using the Fahrenheit, and I'm not using the humidity values. So and check if any reads failed and exit early to try again, so just to check. And over here, if temperature, I'm using two conditions. So if temperature is greater than 32 and T flag equals false, which is already set to false. So if the temperature is greater than 32 and it's false, so what to do? Turn on the relay. So it means that turn on the room cooler, or turn on the exhaust fan, or turn on the ceiling fan, or pedestal fan or any other fan, and serial.println fan is on, and then deflate equals to true. So these instruction will be executed only once. So when the temperature is high, gets high than 32, so it will not be executed again and again. So and these instructions will be executed only when the temperature drops below 32 or it equals to 32 and the deflate equals to true, then which we have already set to true. So if it's true and the temperature is below 32, so then it will turn off the fan, and then again we change the state of the flare and serial.print temperature and serial.print temp. So the programming is really easy. I'll provide a link in the description from where you can download this code and you can change the values. So friends, as you can see, the relay module is connected with the DC room cooler. So this wire is coming from the battery, and this is 12 volt wire. I just cut it this wire. As you can see, if I touch it, if I touch this wire with this one, so you can see the room cooler is turned on, and then it is manually turned on and turned off. So what I did, actually, I just cut it this 12 volt wire, and I connected one end with the common of the relay and the other one with the normally open of the relay. So that's it. This is a relay module, this is the DHT11 sensor module, and the Arduino is already connected with the laptop. Over here you can see it's on. So my friends, it's time to upload the code. So first of all, make sure that you have selected the right board, which is Arduino Uno, and the serial port, which is COM5. Click on the upload button, and as you can see over here, the code is updated. It's uploaded now. And now let's open the serial monitor so that we can see the temperature. And over here you can see currently the temperature in my room is 30 centigrade, and over here I have used a condition which is 32. So when the temperature is greater than 32, then the room cooler will turn on, and when it is below 32, then the room cooler will turn off. So let me apply some heat. So and let's see whether the room cooler will turn on or not. So as you can see, the temperature is greater than 33 and the room cooler turned on. And now let's wait what will happen when the temperature is decreases below 32. So currently the temperature is 34. So that's why the room cooler is on. And now as you can see, the temperature is decreasing. It's now 33. So as you can see, so when the temperature dropped below 32, it's just turned off. So as temperature a little bit fluctuated, so that's why it's turned on. So now you can see the temperature is 32. We use an instruction over there. So if the temperature is below or equal to 32, then the DC room cooler should turn off. So as you can see now, the room cooler is off. So if I increase the temperature again, it will turn on. Let me apply some heat. So as you can see, again it turned on. So we can change the condition, so it will just turn on and turn off depending on the temperature. So it entirely depends on you what value you use for the turning on and turning off, so you can change the condition at any time. Depends on you for what purpose you want to use this. So that's it. I hope you liked today's episode. Like and share my videos with your friends. See you in next episode, and thanks for watching.